Good morning, guys. Today we're going to be talking about types of chemical reactions. This entire lesson is review of stuff that we did in grade 10, and most of it we've actually already reviewed this year. We just haven't used a lot of the reaction types other than neutralization, combustion, and double displacement. So this will be a good review of some of the other types of reactions that we're going to be seeing more of in this unit. Just like in grade 10, you have to be able to identify the different types of chemical reactions. You also want to be able to write the chemical reaction given just the names of the compounds and be able to predict the products of the reaction given just the reactants. Yeah, don't worry about that. So the different types of reactions, again, these are all ones that you've seen either last year or earlier this year. So formation, which is also called synthesis, decomposition, single and double displacement or replacement, combustion, neutralization, ionization, dissociation, endothermic, and exothermic. Those should be numbered 1 to 10. I don't know why there are 2 of every number. So formation reaction, again, also called synthesis reaction. This is when you have at least 2 molecules and they combine to form 1 molecule. Again, don't forget to always balance your chemical equations. So at the bottom there, it says write the synthesis reaction between aluminum and oxygen. In that case, you should start off. By the way, pause this because I'm about to answer it. You should start off with Al, add in some oxygen, which is O2, and you should produce Al2O3. And then, of course, balance it. So you should end up with 2Al. No, let me actually write that out before I tell you what it is. Okay, so you should have 4Al plus 3O2 becomes 2Al2O3, like that. Next up is a decomposition reaction, which is just the opposite of a formation. You take a whole molecule and you break it apart into 2 or more molecules. So if we take hydrosulfuric acid, we can break it apart into a hydrogen molecule and a sulfur molecule. Don't forget about your diatomic molecules. The only time we don't care about whether something is diatomic when it's alone is if it is an ion. But in synthesis and decomposition reactions, we are using molecules, not ions. So then try writing the decomposition reaction for ammonia. Pause me for a second and try that. So for that one, you should start off with 2 NH3, and then it breaks apart to form a nitrogen molecule, so an N2, and 3 hydrogen molecules. So it should look like this. Single replacement, also called single displacement, also called substitution, is when you have a single element replacing 1 element in a compound. So in this case, you'll have 2 reactants and 2 products. On both sides of the reaction, you will have a lone element as well as a compound of some sort. The lone element can be either metal or non-metal, and then it will swap places on the reactant side with either the metal or non-metal in the compound. Metals will switch places with metals, non-metals will switch places with non-metals. The only exception to that is that hydrogen will also switch places with other metals, even though it's not really a metal. So these are 2 examples down here. So hydrochloric acid plus copper becomes copper chloride and hydrogen gas. Again, don't forget, anytime you make an ionic compound, you always have to cross over your charges again. And then here on the other side, sodium iodide plus nitrogen becomes sodium nitride and iodine. Again, crossing over our charges when we make our ionic compounds and checking to see if something is diatomic when it's alone. So pause now and try those two at the bottom there. Okay, so these are the answers that you should have got. So we have magnesium carbide reacting with hydrogen gas. Just remember, when you cross over the charges for magnesium carbide, you do have to put them in lowest terms, which is how we end up with Mg2C. And then our hydrogen gas is diatomic. And then when we switch places, the hydrogen and magnesium are going to swap places. So the magnesium will end up by itself, the hydrogen will end up with the carbon, and then in that case, cross over your charges again, and you end up with CH4, which is methane. And then number 2, we have the potassium oxide, again, cross over our charges and get K2O, reacting with bromine, which is diatomic, so Br2. In this case, the lone element is bromine, so it has to change places with the oxygen since they're both nonmetals. That's how we end up with KBr and oxygen as our 2 products. Don't forget, oxygen is diatomic. Okay, and then double displacement or double replacement reactions are similar to the single replacement, where you have either 2 metals swapping places or 2 nonmetals swapping places. But in this case, there will be no lone elements. It will be all molecules or compounds involved. So at the bottom here, we have sodium chloride reacting with magnesium oxide. And then I find it easier to always have the 2 metals switch places, but you can also do the 2 nonmetals. Either way, you'll end up with sodium oxide and magnesium chloride. Just again, don't forget, when you make those products, you have to recross your charges. So try that one at the bottom. Pause for a second and try that one. Okay, so for that one, you should get that as your answer. So we have lithium chloride reacting with lead sulfate. And then again, swap places with our metals, we will end up with lithium sulfate and lead chloride. Again, don't forget to cross your charges. So with lithium chloride, we cross our charges. They're each 1. We don't bother writing it in. With lead sulfate, sulfate is SO4 and has a charge of -2. And so when I cross my charges between my lead and my sulfate, my lead will have a charge of +4. I know that because of the Roman numerals there. The sulfate has a charge of -2, and then don't forget, we have to put those in lowest terms. So the 2 will cancel out and we'll leave a 2 where the 4 is. So that's where we get the PbSO4(2). Don't forget, when you cross over your charges to something that's more than just a single element, you have to put that thing in brackets. So our SO4 goes in brackets, just like our OH goes in brackets when we do it with a base. And then for lithium sulfate, again, lithium has a charge of 1, so there's not going to be anything behind the SO4 on the product side. Sulfate has a charge of 2, so that's where we get Li2SO4 for lithium sulfate. And then lead chloride, again, it tells us that the lead in this case has a charge of 4. Chlorine has a charge of 1, so that's where we get PbCl4. And then it's supposed to be balanced. So again, it should look like that. Okay. For the combustion reaction, we talked about this when we were doing our gas laws. A combustion is also called a hydrocarbon combustion reaction. It is when you take a hydrocarbon, which is a molecule made of hydrogen and carbon, and you burn it in the presence of oxygen. If it combusts completely, you're going to end up with carbon dioxide and water as the products. If there's not enough oxygen present, then you will have an incomplete combustion reaction where you might have things other than just carbon dioxide and water, like carbon monoxide or just carbon. Fossil fuels are one of the more common types of combustion reactions that we talk about. So things like natural gas or methane, butane, which is used in lighters, propane used in like propane tanks for barbecues, and obviously like gas for your cars and stuff. This is the equation for a combustion reaction. If you memorize that equation, it makes balancing combustion reactions really easily. This tells you how to balance it. So yeah, whatever the like little numbers after the C and H in your hydrocarbon are, you use those based on the rest of this formula to balance your equation. I find it easier to just balance the way we normally balance as opposed to memorize this formula, but you know, whatever you prefer. So yeah, at the bottom here we have the combustion reaction that we talked about probably most when we were doing our gases unit. Methane, if you are doing the combustion of methane, it'll react with oxygen to make carbon dioxide and water. So pause me for a second, try and write the equation for the combustion of C3H8, which is propane, and then come back and see the answer. So the combustion of propane should look like this. Propane plus 5 oxygen, which is O2, becomes 3 CO2 plus 4 H2O. Okay, the neutralization, we talked about that quite a bit in the acids and bases chapter. Again, neutralization always occurs between an acid and a base. The products will always be water and some type of salt. In order to figure out what the salt is, you just remove the H's from the acids, the OH's from the base, and then squish them together, metal, non-metal, recross your charges. This equation does only work for bases that contain a hydroxide. There is other ways of finding neutralization reactions for bases that don't include a hydroxide. In that case, you actually just take the acid and the base and squish it all together. That's what that's there. Okay. So this is showing you why that works. These are the steps of why that works. You don't really have to know that. It shows you an example of what this would look like at the bottom, where we have hydrochloric acid and ammonia, which is one of those bases that don't have an OH in them. And you just kind of squish it all together. So I would have my nitrogen. I have 4 bases if I squish these together, or sorry, 4 hydrogens if I squish these together, because I have 3 from my ammonia and 1 from my hydrochloric acid, and then the chlorine. Okay. Try those reactions. Okay, so these are what your 2 reactions should look like. So in the first one, we have calcium hydroxide, which is CaOH2, plus sulfuric acid, which is H2SO4, becoming 2 waters plus calcium sulfate, which is CaSO4. And then for the second question, we have our hydrofluoric acid, which is HF, plus our pyridine, becomes C5H6NF. Squish it all together. Okay, ionization reactions we also talked about quite a bit in the last unit. So an ionization reaction is when you take an acid or a weak base like ammonia and you break it apart into ions that did not already exist in that molecule. So if it's an acid, you always react it with water in an ionization reaction. an acid will always produce hydronium ions, which are H3O+, and then the other ion is just what you get when you take your hydrogen off. And then for our weak bases, we take our weak base, we once again add water. All ionization reactions react with water. Bases will always produce a hydroxide ion, so OH-, and then the other ion is just add an H and a plus to your base. Dissociation reactions, those are when ionic substances, including bases that have OH, break apart into the ions that make up that ionic compound. So for instance, if you take salt, normal table salt, NaCl, you can break it down into an Na plus and a Cl minus. And then lastly, our endothermic and exothermic reactions. We also talked about this in the last unit. So endothermic reactions is where more energy is absorbed than released, and therefore the reaction will get colder. And sometimes you'll see this written where energy is actually written out as a reactant because it is needed in order for the reaction to take place. Exothermic reactions are where more energy is released than absorbed. We can feel that released energy in the form of warmth coming off of the reaction, and sometimes you'll actually see energy written as a product that's coming out. Okay, that is all. So here are just those answers again, for those of you that couldn't see them in the little tiny video in the corner. So we have our synthesis reaction. This is the example that you guys had to try. Our decomposition, our two single displacements, double displacement, combustion, and our two neutralizations. Okay, so just double check the answers that you had with those, and let me know if you have any questions about it.